Before diving into the details of how Python implements object-oriented programming techniques, let's take a quick refresher of some object-oriented programming principles. So let's begin with some of the reasons and motivations for using OOP in the first place. Now, Python does not require you to use objects or classes when creating your programs, even though everything within Python itself is an object. If you want to create individual functions and variables and data structures and so on, then you're free to do so, and Python will happily execute your code as long as it's syntactically correct. As programs become more complex, however, it becomes increasingly difficult to keep everything organized and to ensure that one part of your program isn't having unintended side effects on another part. Using object-oriented programming techniques helps organize and structure programs. This makes them easier to plan, maintain, and learn by new programmers, even if that's you, like several years in the future, coming back to your code after a while. With this approach, you build a program that groups together data and the functions that operate on that data into one place. This helps reduce bugs and helps ensure that only the parts of the program that need access to that data have it. Object orientation also promotes the building of modular programs, meaning that individual parts of the program don't need to know how other parts work internally. So, down the road, if part of the program needs to be updated or replaced, it can be done with minimal disturbance to the code in the rest of the program. It also helps isolate different parts of the program from each other. So, if a problem occurs in one part of the program, then other parts of the program can continue to operate. All right, so now let's take a quick review of some of the terms we'll see in the rest of the course. You can think of a class as a blueprint or a template that describes how to create a specific kind of object. Methods are a fancy way of referring to functions that are part of a class, while attributes are a way of referring to variables or properties that are part of a class definition. An object is a specific instance of a class or a type. So, for example, the number 1 is an instance of an integer type. The term inheritance describes how you can arrange classes in a hierarchical fashion where a particular class can inherit the capabilities and data of another class, and we'll see how this works in Python later in the course. Another important term to understand is composition, which refers to building complex objects out of other objects. And again, we'll see an example of this later. All right, so now that we've had a quick refresher on object-oriented programming terms and principles, we can get started with the rest of the chapter and see how Python puts these into practice. If you're still unsure about some of these terms and principles, I would encourage you to review the What You Should Know video at the start of this course for some direction on where you can learn the basics before continuing.